Okay, so now let's understand what Gini impurity is. I'll write the formula for Gini impurity. It's given by I subscript G. This is not information gain. Information gain is written by capital I, capital G. Gini impurity is written by I and subscript G, okay? So Gini impurity of Y is given as 1 minus the summation of I equals 1 to K, where K is the number of classes, P of yi the whole square. Okay, so if you have two classes, it's basically 1 minus probability of y equal to yes the whole square minus probability of y equal to no the whole square. Okay, so where is Gini impurity used? Well, Gini impurity can be used instead of using entropy. We saw how we used entropy to build the decision tree, right? We can do the same thing. We can just, all we have to do is replace Gini impurity with entropy and then calculate the information gain the same way that we did. Okay. So now why use Gini impurity? Well, the thing is, calculation of Gini impurity does not require log. The thing is, log is a little computationally intensive to calculate. And when you have a huge data set with millions of rows, then it gets a little time consuming to calculate entropy over Gini impurity. Okay, so let's understand the characteristics of Gini impurity. Let's say I have two classes, y plus and y minus, and both the classes are equally divided. Okay, one by half and one by half. So my Gini impurity will be 1 minus half the whole square minus half the whole square. Okay, this is 0.5, right? Now let's say I have a class where, they're skewed. I have y plus equal to 1 and y minus equal to 0. There are no points in the negative class. In this case, the Gini impurity is 1 minus 1 the whole square minus 0 the whole square, which is equal to 0. So it's easy to see here how Gini impurity varies over entropy, okay? So if I have P of y, which is the class, and I have the value of entropy slash Gini impurity over here, then entropy varies as such. At 0.5, the maximum value of entropy is 1. But the maximum value of Gini impurity is, let me just change the color. The maximum value of Gini impurity at 0.5 is not 1, it's 0.5. That's it. That's the only difference between entropy and Gini impurity, except for the formula, of course, is that the chart or the graph of Gini impurity with entropy is it's half of it. And why we use, again, to reiterate, why we use Gini impurity over entropy is because it's easier to compute, because it does not have a log. This is basically just adding and squaring, right? Squaring is less computationally intensive than calculating log. So it's a little time consuming to calculate entropy, and sklearn also uses Gini impurity. But to build the decision tree, you can use either one of them, either Gini impurity or entropy. So yeah, that is what Gini impurity is all about.